Okay, so let's look at a slightly more difficult problem. This one wants us to find V1, V2, and I1 using nodal analysis. Okay, uh, and notice here that we have a few different parts and pieces. We have current sources instead of voltage sources, and we've got multiple points of unknown values. So we're in a bit of a pickle, but it's going to be fine. All right, so if we're using nodal analysis like they ask us to, something we're going to do at first is to go drop a ground somewhere. Okay, so 1, 2, 3, V of G is equal to 0. And our method is for multiple unknown points. I'll write the method up here. We're going to assume all currents are exiting except for known current sources. Okay? And for this problem, we'll use enter as negative and exit as positive. And that just makes your math a little bit more simple to follow through. It can cause less errors because multiplying that negative out can trip people up every now and then, and these problems can get lengthy. Okay, so if we go and we look at these here, so I'll call this I of A, call this one I of B. We know that 2 amps is going in that way, and we know that 1 amp is coming in this way. All right, so let's go look at V1, so point V1. So V1, we're going to assume it's doing this. I1 going that way, IA going that way, then 1 amp coming in. And we'll write out negative 1 amp. I'll do plus I1 plus IA is going to be equal to 0. And if we go use V is equal to IR, where I is equal to V over R, we can say here, negative 1 amp plus for I of 1, it looks like we're going from, I'm sorry, let's do I of 1. I of 1 is going to be V of 1 minus V of 2 over 10, because we're just going from here to there. And then I of A is going to be V of 1 minus V of G over 20. That'll be equal to 0. And if we go simplify this down, we'll get negative 1A plus 1/10 V of 1 minus 1/10 V of 2 plus 1/20 V of 1 is equal to 0. Remember, V of G goes to 0. So combining like terms, we're going to get 0.15 V of 1 minus 0.1 V of 2 is equal to 1. Okay, now if we go look at V2, so V2, we'll have 2 amps coming in this way, we'll have I of B going down, and then we'll have I of 1 going that way. We're assuming it's going to go the opposite way. All right, so if we could write our law out, so minus 2A plus I1 plus IB is equal to 0. Once again, I is equal to V over R. So minus 2 amps plus I of 1 is going to be now V of 2 minus V of 1 over 10, because now we're going from V of 2 to V of A, or V of 2 to V of 1. And then I of B is going to be V of 2 minus V of G over 5. And that's because we're going from there to ground. That's equal to 0. All right, if we combine like terms, plus 1/10 V2 minus 1/10 V of 1 plus 1/5 V of 2 is equal to 0. Okay. And if we simplify it down, we should get negative 0.1 V of 1 plus 0.3 V of 2 is equal to 2. All right. And I'll just write, we'll go ahead and solve for, so we'll do plug and chug. V of 1 is equal to, from equation 1, V of 1 is going to be equal to 1 plus 0.1 V2 over 0.15. And if we divide 1 by 0.15, 6.67, and then 0.1 by 0.15 plus 0.67 V of 2, so V of 1. So I into I dot dot, we will get that here, V of, or here, let's just do this. We'll rearrange 2 into a form of I1. So we'll do I. We will get V of 1 is equal to negative 2 negative 2 plus 0.3 V of 2, which distributed that negative sign right there, over 0.1, and that should give us negative 20 plus 3 V of 2, that's equal to V of 1. So if we set the first equation to the second equation, we will get 6.67 plus 0.67 V of 2 equal to negative 20 plus 3 V of 2. And we solve for V of 2. It looks like 2.33 V of 2 is going to be equal to 26.67. So therefore, V of 2 is going to be equal to 11.44 volts. And if we just take that value and go plug it into like the first equation, then we'll get 0.1. Actually, we can just do this. We can just do V of 1 is equal to 1 plus 0.1 times 11.44 volts over 0.15. And if we do that quick math, $14.33 volts for V of 1. Okay. So what does that mean? So V of 1 is greater than V of 2. So if we go from here to there, V of 1, V of 2, current flows from the higher voltage to the lower voltage. And we're crossing over, I believe it was 10, yep, 10 ohms. So I of 1 is going to be equal to V of 1 minus V of 2 over 10, which will give us 0.289 amps for I of 1. All right. That is the end of this SI session. Thank you so much for watching.